Now let's go to multiplication of vectors. There are two ways to multiply vectors, and the first one is dot or scalar product, which is defined as a dot b is equal to ab multiplied with the cosine of theta. Now given these two vectors a and b, and theta as the angle between them, now in getting the dot or scalar product, we multiply a with the cosine of b cosine theta. So the orthogonal, or b cosine theta, is the orthogonal component, which is similar with the direction of a. So it's an orthogonal component. So vector b has two orthogonal components. So this one, okay, so this is b x. So let's say bx, and then this is by, although it's not necessarily on the x-axis and on the y-axis. I just use it for to differentiate the two. Now again, this is the orthogonal component that is parallel or has the same direction with a, while by is the orthogonal component which is perpendicular with a. So we can also write a dot b as ax bx plus ay by plus az bz, and then to get cosine theta, so that is a dot b over a b. Let's say, for example, we are asked to calculate for the dot product of u is equal to 6i plus 8j minus 3k, and v is equal to 7i minus 9j plus 5k. Remember that I dot I is equal to 1, j dot j is equal to 1, and k dot k is equal to 1. But if we get the dot product of I dot j, so that is equal to 0. I dot k is also equal to 0. K dot j is equal to 0. Why? Since we have a formula, a dot b is equal to a b cosine theta. Now if cosine or if theta is 90, so cosine 90 is equal to 0, while cosine 0, sorry, let me erase that. Okay, cosine 0 is equal to 1. So therefore, I dot I, the angle between them is 0, so that's why it's 1. J dot j, again the angle between them is 0, that's why it's 1. However, for I dot j, the angle between them is 90 degrees. Therefore, cosine 90 is 0, so that's why all of these three are zeros. Now, given this, or considering this, so u dot v is equal to, okay, 6i and then 7i, so that is 42. So we don't have to write, diba? 6 times 7 is 42. I dot I is 1, so we don't have to write 1 anymore. So 6i and then negative 9j, that negative 9j, so I dot j is 0, therefore it's 0, so we don't have to write that. Similarly, 6i dot 5k, so I dot k is 0, so again, so that's 0. Now 8j dot 7i, it's 0, again, since I dot j is 0. 8j dot negative 9j, So that is negative 72, since 8 times 9 is 72, and j dot j is 1. And then lastly, again, k and I 0, k dot j is 0, and then negative 3 dot 5k, or negative 3k dot positive 5k, so that is negative 15. Therefore, u dot v is equal to negative 45. So now in this case, if the dot product of two non-zero vectors is positive, then the two vectors point in the same direction, or the same general direction, meaning less than 90 degrees. If the dot product is negative, then the two vectors point in the opposite direction, or above 90 degrees, which is less than or equal to 180 degrees. The second way to multiply vectors is cross product or vector product, or C is equal to A cross B, where C is A, B sine of theta. Now note that C is perpendicular to both A and B. Now here we multiply the vector B or vector A from the component of B that is perpendicular with A. So which gives us the answer that is also perpendicular with the two vectors, or the plane containing the A and B vectors. Now if we are given with two vectors with 3 dimensions, so A is equal to AXI plus AYJ plus AZK, and B is equal to BXI plus BYJ plus BZK. If we want to know A cross B, we have to follow this process. Now since A cross B is equal to AB sine theta, therefore if sine theta is 90, that is equal to 1, right? So if sine 0, that is equal to 0. Therefore, if we have I cross I, so I is perpendicular, or so I has the same direction with I, therefore the angle between them is 0, therefore I cross I is 0. Similarly, J cross J, that is also equal to 0, and K cross K, that is also equal to 0. Now what if we have I cross J and J cross K, and then K cross I? So remember this rule. So if we have I, J, and K, so the process or the sequence should be always like this: AJ, and then JK, and then KI. I cross J, the product is K hat or K. J cross K, the product is I, and then K cross I, the product is J. But if it's in the opposite direction, so let's say I, J, K, I cross K, so that is negative J, K cross J, that is negative I, and then J cross I, that's negative K. So these are the rules. So therefore I cross J is equal to, so I cross J is equal to K. J cross K is equal to I, while K cross I is equal to J. Okay. And when you reverse that, so J cross I is equal to negative K, and then K cross j, that is negative I, and lastly I cross k, that is negative j. Now if you want to cross A and B, so that is equivalent to A xi plus ayj plus azk, and then cross with bxi plus byj plus bzk. Now let's do it one by one. So A cross B, so AXI cross BXI should be 0 since I cross I is 0. Now AXI BYJ, so I cross J is K, right? And then that's why we have A X B X, and then that's K. Okay, now next is AXI and then BZK. So I cross K is negative J. Okay, so that's why negative AXI, sorry, AX, let me erase that. Okay, AX BZ, so that's J. Okay, next is AYJ cross BXI. So J cross I is negative K. So that's negative AY BX K. Okay, next is J cross J, which is 0, so we don't have to write that. And then AYJ and then BZK. So J cross K is positive I. So that's AY and then BZ and then I. Okay, next is this plus AZK and then BXI. So that is positive J. So AZ BX K cross I is J. Then AZK BYJ, that is K cross J is negative I. So negative, sorry, that's A Z BY I. Okay, and then AZ BZK, so that's 0. Now let's combine similar terms or similar directions. So this is equal to AY BZ, so ito AY BZ, and then this one minus AZ BY, then quantity I, plus, okay, so this first, where is it, J. Okay, negative AX BZ, and then where's the other one? Yeah, here, plus AZ BZ, so this is J. And lastly we have K, so AX BX, so this is X, sorry, and then the other one is here, minus AY BX and then K. So this is A cross B. Now since we have a negative here, we can just make this negative so that this becomes positive and this becomes negative. So therefore our final equation will be, okay, so this becomes minus here, and then let's make this positive, and let's make this negative. So this is A, this is B. An easier way to do this is to use matrix notation. So when we use matrix, so let's just write I here, J, and then K, and then AX, AY, AZ, and BX, BY, and then BZ. Okay, now so we have A cross B. Now if we want to get the X component first, or the I component first, so we will disregard this first, and then we will use this. Okay, A times B, or AY BZ, so that's AY BZ, then minus, it's always minus this one. So it's like this. You have A minus B, or A times B, and then minus this one, AZ BY. Okay, so AY BY Z, or BZ, minus AZ BY, and the directional is I hat, or I, and then we have to add or plus. Okay, so this time it's J hat, so, or J. Now if you want to get the direction in J, so we have to cover this, or we have to disregard this, and then to make it easier, this is the technique I'm using. I just write I here, and then AX, and then BX, and then it would be easier for me to do this, AZBX minus AXBZ. So let's try that. So AZ, sorry, it's AZBX minus AXBZ. Okay, next. So we have K next. Okay, so to get K, so we have to disregard this, and then we do AXBY minus AYBX. So that is AXBY minus AYBX. Now this is the final answer. We were able to get the cross product of AX, A cross B. For example, we are asked to calculate the dot product of U and V. So U cross V. So that is equal to, let's use it's easier if you're going to use the matrix notation. So I, J, and then K. And then we have 6, and then 8, -3. Don't forget to include the negative. And then 7, 9, and then 5. So -9 here. Okay, so that's why U cross V is equal to, so first let's get the value of in the direction of I. So here we have I hat, or I, sorry. So let's disregard this first, and A, or A times 5 is 40 minus 3 times 9, which is 27. So that is 40. So negative 27, or so negative 3 times negative 9 is positive. So negative 27 minus 27 plus, okay, on the j hat. So again, we disregard this, and it for to make it easier, so I'll write 6 and 7 here, so it will be easier for me to do this. Negative 3 times 27 is negative 21, minus 5 times 6 is negative 30, or 30. So, and then negative 21 here, minus 30 j, and then plus, now k hat, so disregard k, and then we do this. So 6 and negative 9 is negative 54, minus 7 and 8 is 56. Okay, so negative 54 minus 56. So that is now 40 minus 27 is 13 I hat, or I, plus, okay, negative 21 and 30 is negative 51, so this should be negative. Okay, so this should be minus 51 j plus negative 54, and negative 56 is 110. But since it's negative, let's make this negative. Okay, k. Okay, so this is now the final answer. Next is the scalar triple product. So it's a combination of a cross product and a scalar product. So, but first, you have to cross A and B first, and then multiply it with C using the scalar product. But a faster way to do that is to use the vector the matrix notation. So if A is equal to AX I plus AY J plus A Z K, while B is equal to B X I plus B Y J plus B Z K, while C is equal to C X I plus B Y J plus B, C na pala. Okay, C Y J plus C Z K. So A cross B dot C, it's A Y, or AX BX here, CX here, and then AY BY, and then CY, and then CX, Z AZ BZ, and then CZ. So for example, we are asked to calculate the triple product of A is equal to 7i plus 5j, while B is 2i minus j plus 2k, and C is 3i plus 2j minus k. So if A cross B dot C, So we can simply get the cross product of A and B and then multiply it with C. So A cross B is, okay, so let's use the matrix notation. So I, J, and K. So 7, 5, 0, and then 2, negative 1, and then 2. So therefore we have, okay, so let's get this first, I. Okay, so 5 and 2 is 10, and then 0, so 0, so minus 0, plus, so 10 is, again, so J muna, then K, I, 7 and 2. Okay, so therefore if we cross this, 0 and 2 is 0, and then 7, 2, so that's minus 14. J plus, okay, K. So for K, so let's disregard this. So 7 and 1, 7 and negative 1 is negative 7 minus 10. So therefore, our final equation for this is 10I minus 14J minus 17K. Now let's multiply this answer with C. So that is 10I minus 14J minus 17K times, let's dot with C, so that is 3I plus 2J minus K. So that is 10 and 3 is 30, and then 14 and 2, negative 14 and 2 is negative 28, and 17 and 1 is negative, so positive 17, since they are both negative. Therefore 30 minus 28 plus 17, that is equal to 19. So therefore this is the final answer. A cross B dot C is equal to 19. So it is called scalar triple product since the product will be a scalar quantity. So notice that we don't have any direction here. So that is multiplication of vectors. Thank you for watching.